Welcome back. Today we're going to be going over a project that many of you guys can make. You can use practically any language you want, but for my implementation, I decided to use C++. This is a stack-based programming language, and I'll go over what a stack-based programming language is. Now, why would we do a stack-based programming language? The reason why is that it's relatively an easy project, which I know sounds weird that programming language and easy project is in the same sentence, but it is a lot easier than implementing, let's say, like a fully featured systems language like C or like C++ or Rust or whatever. It's much easier than that. And it sounds very impressive, teaches you a lot, and it's not very time consuming. This project will also kind of catapult you into making like a different paradigm language, like a procedural programming language or an object oriented or like a functional programming language. We're going to start off by defining the syntax for our language. And while we're going over the syntax, I'll explain what a stack-based programming language is. Think of your command processor. When you think of it, you see a prompt and you typing in values. Think of the stack-based programming language similarly, where it executes line by line and it does every single operation on a stack. I assume you know what a stack is, and if you don't know, think of a stack of books. We can push or put values onto the stack, and we can pop values off the stack by removing the book. That's basically what a stack is. And again, I assume you know what it is, but I'm just saying that for a refresher. Okay, so I realized later when editing the video that I did not mention that we're not going over any conditional statements, functions, records, or structs, structures, objects, whatever you want to call them. We want to keep this programming language simple for now. We can add these later. I may add them later. However, I might also leave it up to you guys to add them later. I'm aware of it and it's intentional, so don't be surprised when we don't have if statements or functions or anything like that. We're just trying to keep things simple for now, take one step at a time, make sure we don't overwhelm ourselves. So for the syntax, what we can do is that we can push a value onto the stack. Next, what we can do is that we can add the values, which pops the top two values out, adds them, and then pushes the result back onto the stack. Sub, mul, div, and mod do the same thing, but their operations are different. Instead of adding, they subtract, multiply, divide, or modulus. Duplicate duplicates the top value. Sorry, dupe duplicates the top value on the stack. Swap will swap the first two values. Pop will remove the top value. It won't store it anywhere, it just removes it. And print will print the top value. If you still don't understand how this will work and how a stack-based programming language will work, here's a nice little explanation on the sample code that I've made. Push 10 will push 10 onto the stack. Push 20 will do the same as before, but instead push 20. We will remove the first two values on the stack, which is both 10 and 20. Sorry, not first two, but the top two values on the stack, 10 and 20. Add them, push them back onto the stack, which will now be 30, and then print, which will print 30. If that didn't make sense still, I have a nice little simulation. So let's start off with the source code on the side, which is what we just went over. And the left is the stack. First, we push 10 onto the stack. We move on to the next line of code. Now we push 20 onto the stack. Moving on to the add function or the add instruction. We add those values onto this, add the top two values on the stack and push it back. And then finally, onto the last instruction, we print the top value. So all of this code will result in this specific value. Creating this isn't very difficult, like I mentioned before, but it requires a bunch of steps. And for now, this video is just going to go over the syntax for it, which we just did. And I will likely make this into a multi-part series where we go over each section in kind of a modularized form so that it's a lot easier to digest and you can make the code in pieces rather than trying to digest it all at once in one whole video. Plus, some of these sections are a lot shorter than others. For example, this section is a lot shorter than, let's say, tokenizing, parsing, IR, or code generation, or execution. All these other sections, they may vary in length. So putting them all in one video just doesn't make any sense. Thank you guys for watching. Stay tuned for the rest of the parts of this series. At the end, you should have a functioning programming language, more specifically a stack-based programming language that you can put on your resume, your GitHub, or whatever, wherever you'd like. Let me know what you guys think in the comments below. Leave your feedback. I always read your feedback. Let me know what you guys think. Anyways, thank you for watching. Bye.